Hi there, this is GCSE Forces Lesson 21. This one's on uniform acceleration, and the objective is to apply the uniform motion equation. So a quick recap first on what gravity is. So gravity will cause objects to fall or to accelerate. So remember, a falling object is subject to an acceleration of 9.8 meters per second squared whilst on the surface of the Earth. This might come in useful if there's any questions where a mass is falling on the surface and you need an acceleration. It will be 9.8 meters per second squared. Okay, let's move on. So you're going to need a new equation, and it's v squared equals u squared plus 2as. Okay, v is the final velocity measured in meters per second, u is the initial velocity, also in meters per second, a is the acceleration, meters per second squared, and s stands for displacement, which is measured in meters. Okay, if you want to write that down, we're going to use that in a moment. First of all, let's do a quick recap of the original velocity and acceleration equation which we were given. So here we go. If you can remember this equation without any help, please pause and have a go. If not, it's the v equals u plus at. So if you want to have a go at this one first before we move on with the new one. So a line at rest accelerates at a constant 5 meters per second squared over a period of 3 seconds. Calculate the speed of the line after this time. So the line was originally at rest. So that would be, u would be 0. So v equals at. So the speed v is equal to the acceleration 5 times time 3 seconds. So that gives us 15 meters per second. If you had no idea about that, you might want to go back and watch the acceleration video, which is GCSE Physics Forces Lesson 17. Okay, let's get on to the new one. Okay, if you want to have a go at this one, please do. And then I'll take through the answer. So, a ball is dropped from the top of a building. When it is 2 meters from the ground, its velocity is 10 meters per second. Calculate the velocity of the ball when it hits the ground. So what we're going to do is to use the v squared equals u squared plus 2as, which we just wrote down earlier. And we want the velocity v. So let's see what we know. We know the distance it's going to travel, or the displacement, is another 2 meters. And we know the initial velocity is 10 meters per second. There isn't an acceleration, but remember, this is falling. And I said to you earlier that, remember, if it's falling, the acceleration is equal to 9.8 meters per second squared, because the acceleration is due to gravity. Now, typically, we would have to give a direction as positive for this. So, because obviously we're dealing with vectors, we'll take down as positive. So anything going downwards is positive, and everything is down, so it's okay. So we want the velocity, so v squared is equal to, so we've got the initial speed squared, so we're looking at it from 10 meters per second, so we need to do 10 squared plus 2 times the acceleration, so 2 times 9.8, times the distance it's traveling, or the displacement, which is 2 meters. And then obviously that's v squared, so we need to square root whatever that answer is. So v is equal to, and it'll be the square root of 139.2, and that gives us 11.8 meters per second. Right, let's look at rearranging the equation now. So how to rearrange? So we've got the equation v squared equals u squared plus 2as. Let's imagine we wanted the displacement to be the subject. So we need s on its own. So first of all, let's get rid of a plus u squared. So plus u squared, to move it to the other side, is obviously minus u squared equals 2as. Then to isolate s on its own, we need to get rid of a times 2 times a. So the opposite of timesing by 2a is dividing by 2a. So it would simply be v squared minus u squared divided by 2a to give us the displacement. Okay, let's do another one. So you can write this down if you need to. Accelerations are the same, so it would just be v squared minus u squared divided by 2s. So it's the exact same technique, but at the end, instead of moving the a to the bottom, we move the s instead. The other one I want to show you is to rearrange to find u squared, because sometimes students can get confused with this one. So the original equation, v squared equals u squared plus 2as. And what we want is the initial velocity, so u. So to do that, we just need to get rid of the plus 2as. And obviously the opposite of adding 2as is to simply subtract 2as. So v squared minus 2as will give us the initial speed squared. And then once you've got the initial speed squared, you can just do the square root, which I'll write in anyway. So square root of v squared minus 2as would give us the initial velocity. So hopefully that'll help for the next questions coming up. So let's move on to those. So practice time, if you want to pause and have a go at these 3 questions. And then once you've had a go at them, if you press play, I'm going to take you through them all step by step. Okay, so let's move on. So a runner is running at a steady speed of 4.8 meters per second. When he is 45 meters away from the finish line, he accelerates at a uniform constant rate. Velocity at the end of the race was 6.8 meters per second. Calculate the acceleration. So the equation, v squared equals u squared plus 2as. And we need to rearrange initially to find the acceleration. So remember, we need to get rid of a plus u squared, so it's v squared minus u squared equals 2as. And then we need to find a on its own, so we need to get rid of the times 2 times s, so we need to do the opposite and divide. So it's v squared minus u squared divided by 2s. And it's just a matter of putting our numbers in. So the final velocity is 6.8, so we need to do 6.8 squared and subtract the initial velocity of 4.8 squared, and then divide by 2 times s. So 2 times 45 is 90. And if you put that in your calculator, you should get 0.26 meters per second squared. Hope that went okay. Let's have a look at the next one. A ball is dropped from the top of a building. When it is 3 meters from the ground, its velocity is 8 meters per second. Calculate the velocity of the ball when it hits the ground. So, v equals u plus at. Sorry, wrong equation. V squared equals u squared plus 2as. Should be pretty straightforward because we're looking for the final velocity. Let's look at what else we know. We know the displacement is going to be 3 meters. And the initial velocity is 8 meters per second. Because this is falling, we know that the acceleration due to gravity is 9.8 meters per second squared. Okay, so let's go. So it's v is equal to the square root of u squared, so that's 8 squared, plus, now remember everything's falling downwards, so everything's positive anyway, so it's plus 2 times 9.8 times 3 meters. So if we calculate that, should be straightforward, we should get 11.1 meters per second. Okay, let's move on to the last one. So this one, an enthusiastic physicist falls out of a tree and hits the ground at 7 meters per second. Calculate the height of the tree. So v squared equals u squared plus 2as. And we want height, so we need to rearrange it first. So it's v squared minus u squared, remember. And that equals 2as. And then we need to get rid of the 2a, which is multiplied. So the opposite of multiplying 2a is dividing by 2a. So it's v squared minus u squared divided by 2a. And that gives the displacement s, or in this case, the height of the tree. Then we just need to put our numbers in. So the final velocity is 7 meters per second, so that's 7 squared, minus the initial velocity is 0, because the person's in the tree. So 7 squared minus 0 squared is obviously just 7 squared, divided by 2 times the acceleration. Remember the acceleration, as it's a falling object, is 9.8 meters per second squared. So we need to divide that by 2 times that, so that's 19.6. So the final one is, so 7 squared is 49, divided by 19.6, and if you put that in your calculator, you'll get height of the tree to be 2.5 meters. So what I've got here is a bonus question. Apologies for any handwriting that's not very neat. So if you want to pause and have a go at that one, and then I'll take you through the answer now. So it's a bit of a tricky one, this. So a ball is thrown vertically at 10 meters per second. Calculate the maximum height reached. So there's not much information given to us. So let's write the v squared. Oh, sorry. That went a bit funny. There we go. V squared equals u squared plus 2as. Now on this one, we need to select a direction as positive, and because the ball's being thrown vertically upwards, I'm going to pick up as positive. So what we need to do is rearrange to get s first of all. So we've done a few of these now. So v squared minus u squared divided by 2a. 2a. And that'll give us the displacement, s. Then we just need to put our numbers in. So the final speed, now if you think about it, if you throw a ball upwards, when it reaches its maximum height, its velocity is going to be 0. So that's just 0 squared. Minus the initial velocity squared is, well, the initial velocity is 10, so that's 10 squared. Divided by, now the acceleration is the acceleration due to gravity, but gravity is acting downwards. The acceleration due to gravity is 9.8 meters per second squared. But because it's down, it's in the opposite direction to what we gave positive to. It's a negative value, so it's minus, well, it's 2 times minus 9.8. So that gives us minus 19.6. And that'll give us the displacement. So 0 squared minus 10 squared is, well, we've got minus 10 squared, which is minus 100. Divided by, that is not the same, by the way, as doing minus 10 times minus 10. It's kind of like this. So it's minus 100 divided by minus 19.6. And if you put that in your calculator, that will give you the maximum possible height reached, which is 5.1 meters. Hopefully you found that video okay, a little bit challenging. If you're good at maths, though, you should be okay. And if you're okay at maths, hopefully we've done enough practice to facilitate your understanding. So thanks for watching anyway, and I'll speak to you soon.